Good evening. I'm Michelle Judd, and as the Executive Director for the WM Keck Institute for Space Studies, or KISS, I'd like to welcome you to tonight's event. KISS is a joint think tank between the Caltech campus and the Jet Propulsion Laboratory, or JPL, and we hold studies on ways to revolutionize space exploration. We're privately funded and every dollar counts for us. So I'd like to give a very special thank you to our individual private donors and the Caltech Space Innovation Council, who are helping raise funds for our work to continue. While the lecture series is open to the public, we designed it for our KISS affiliates in mind. Nominated by the Caltech faculty, KISS affiliates are an ongoing cohort of campus graduate students and postdocs who are seen as the next generation of space exploration leaders. The series introduces the affiliates to astronauts, researchers, chief engineers, and as evidenced today, industry CEOs. Introducing our speaker today is Serena Lupu, one of our 2020 KISS affiliates. Serena is currently a second-year graduate student at Caltech working on problems related to autonomy and control for spacecraft and space robots. When she isn't thinking about how to use robots to help colonize other planets, Serena builds and launches her own rockets. So Serena, it's time to count down to the main event. Take it away.
Thanks, Michelle, for such a great introduction, and thanks everyone for joining us today. I'm honored to introduce Dr. Sara Spangelo, the co-founder and CEO of Swarm. Swarm is making data accessible to everyone, everywhere on Earth, by providing affordable satellite communication services to people and devices in remote regions. Swarm has already 81 satellites in space and will almost double this number by the end of 2021. Before starting Swarm, Sara worked on small satellites and autonomous aircraft at the University of Michigan and was a lead systems engineer at both NASA Jet Propulsion Lab and at Google X. At Google X, she worked on Project Wing, which is one of the most famous drone projects at the X company. Her expertise is in modeling and optimizing satellite constellations to maximize impact and business opportunities. Sara holds a PhD in aerospace engineering from the University of Michigan, and in 2017, she was a top 32 Canadian astronaut candidate. In addition to all of this, she is an avid runner, swimmer, biker, a private pilot, and enjoys triathlons. Also, she practiced ballet for many years. We are so happy to have you here tonight. If you have any questions for Sara, please feel free to use the Q&A section on Zoom. Now, Sara, the virtual stage is all yours.
Thank you so much. I'm just going to share my slides here. So great to be here. This is one of our little satellites. I'm going to start by introducing myself, then talk about Swarm, and then talk a little bit about my vision for connectivity in the future. So a little bit about me, a little bit about my background. Very kind of normal childhood. I actually grew up in Canada. Did a lot of dance, swimming, playing with Legos, driving my parents crazy by them stepping on Legos. And I think a really pivotal moment for me was when I had the opportunity to attend space camp in grade 8. And this was in Montreal, and it was en français, so very challenging. And that was a pivotal moment for me where I had the opportunity to experience the moon wall and all of these kind of mock mission opportunities and learn about a lot of the physics and science that go into aerospace and space exploration. And I really came away from that opportunity very inspired and had in my head that I wanted to become an astronaut when I grew up. And I, kind of have had that vision and that drive ever since that moment. And that really led to a lot of my academic and later career decisions. And my parents and my school and teachers and friends were very supportive of that. So no one ever made fun of me. And therefore I was enabled and motivated to kind of keep that dream. So I ended up studying first physics and astronomy at the University of Manitoba, which is where I grew up. And a little bit about my family. There's a lot of engineers in my family. My parents are civil engineers. My grandpa was a mechanical engineer. So in order to rebel against that, I thought I'd never go into engineering. But after a year in physics and astronomy, I actually ended up pivoting and studied mechanical engineering. And then once I finished my degree, I love being in school. I love my undergrad. One of the kind of funnest times of my life, which probably shows how much of a nerd I am. I always wanted to go a little bit deeper in all of the topics that I was learning. So applied to go to a master's program and ended up going to the University of Michigan, so a different U of M. And I did my master's and PhD there in aerospace engineering and had the opportunity to work on drones as well as on satellite constellations. My PhD focused on optimizing constellations. And I also had the privilege of working on CubeSat projects, which are small satellite missions. I'm sure many in this audience are very familiar. And we actually flew one of the first science-funded NSF CubeSats called RAX around 2010 to 2012, and got to design, test, and operate these satellites. And that really opened my eyes to the world of space and working on real missions, which was very exciting. So throughout my career, I obviously started in academia, getting my master's and PhD. And then I did seriously consider becoming a professor for a while and applied to multiple schools and had some opportunities. Ultimately decided I wanted to pursue more of the industry route. I was at JPL and NASA for 2.5 years, which was, again, an incredible opportunity. I had so much fun at JPL, so many incredible minds, incredible projects. I got to work as a lead systems engineer for one Discovery class mission and several other small sat missions. And I attended a few KISS workshops while I was there. Michelle was kind enough to share some photos of me in the bottom right-hand corner. You can see that about 10 years ago at the KISS and Keck events. And as a young grad student, I have to say these events, first of all, I felt very privileged to be even invited. And they were just so inspiring. And I got to be surrounded by all these great JPLers that I looked up to and other scientists. And it really motivated me to want to work at JPL and pursue a career. So thank you to the Institute for everything that you provided. And I think back very fondly to those events and look forward to them being in person again someday. And then after about 2.5 years at JPL, I switched over to industry. So I had been consulting for a while for software and engineering companies, and then ended up taking a role at Google X. Google X has an autonomous drone delivery program called Project Wing. So I worked on that for about a year. I also worked on a secretive satellite project that I started there. And again, that was an incredible opportunity. Learned so much. Google X really tries to push products into the real world really fast and use that as a learning experience. And I think that that's something that's definitely benefited us at Swarm. The satellite project was also kind of an intrapreneurship opportunity. So I still had the perks of lots of healthy and amazingly delicious food at Google and massages and gym and great salary, but was also able to pursue my kind of dream of a future satellite program. And I think without that opportunity, I probably wouldn't have had the confidence to try to start something outside of Google. So I'm very grateful for that opportunity as well. And then in the startup land, I also consulted for a few startups and then ended up founding Swarm with my co-founder, Ben Longmire. And we've been doing that for the past 4 years. So that's been the big chunk of my life. And a lot of my talk will focus on what Swarm is trying to do and our kind of roadmap towards that. And then on the hobby side, these were mentioned in the intros, but I try to do stuff outside of work, less now than before with the craziness of a startup. But I do have my pilot's license. That was something that I started to pursue kind of as a treat to myself after going through the PhD program and ended up finalizing or getting my VFR, license when I was working at JPL in Southern California, which is a great place to learn because the airspaces there are incredibly complicated. So any place you fly after that, even the Bay Area, will be easier. And then did my instrument rating out here in the Bay Area as well. I also have done scuba diving, I like to work out, as was mentioned. I love to travel, mentor and advise different companies and young scientists and engineers. And then I did have the opportunity to try out for the Canadian astronaut program. You can see some pretty embarrassing photos of me. The bottom three on the left-hand side are me trying out, and that was a very humbling experience. Unfortunately, I got cut from that program, but overall was still super fun and got to meet a lot of amazing Canadians. It was okay because it was right when I started Swarm. So I was able to, that the decision was kind of made for me in terms of where to focus. But I also think that the experiences that we went through there, you can see me almost drowning in that middle photo and trying to fix some sort of electronic system, and the one on the right. It was also a pretty good experience of, we were literally fighting fires. That was part of the training, and they try to stress us out and make us break. And I feel like that was also very good training for running a startup. Things are generally not actually on fire. So I was always kind of go back to that experience. So now I'm going to pivot over and talk about Swarm. So we started Swarm, like I mentioned, about 4 years ago. And we are a venture-backed startup in the Bay Area. We have about 30 employees, growing pretty rapidly. And we've raised a total of about 35 million across a few different raises. And yeah, it's been quite the adventure. So I'd love to just kind of jump in and tell you more. And we also have a website, swarm.space, if you ever want to check out more about us. So we really started Swarm realizing that we have a huge connectivity problem on this planet. So many of us take for granted that we have connectivity in our homes and our cities. But when you look at it on a global scale, 10% of the Earth's surface area and 35% of the land area has connectivity. There's 90% of the Earth's surface area that remains disconnected today. And that has pretty tremendous impacts, not only on people, but also on the assets that are covering the Earth's surface area. And that's really the problem space that we started out trying to go after. So we view our mission, and it's been this way since the very beginning, 4 years ago, is to connect people and devices anywhere at all times at the lowest cost. And the cost piece is interesting. So, there are very expensive traditional legacy satellite systems that exist today. Many of them have very large dishes like this that are required. So they require a lot of CapEx, very costly data services. We're talking hundreds, thousands, tens of thousands of dollars a month for limited amounts of data. And often the equipment is large and quite power hungry. And often these solutions, because they're sold through resellers, they're pretty painful to buy satellite solutions. And my co-founder, actually, Ben, has a great story. When he was working at Apple, he was trying to buy a satellite solution to track high altitude balloons. And he was on the call with someone who was supposed to be the tech support. And because it was a reseller, they just didn't know much about the tech, didn't really care. It's Saturday night, no one's answering. And he was just flabbergasted that he was willing to pay a lot of money to get connectivity in a remote location. And it was basically impossible. And given that experience with high altitude balloons, that's just one asset that wanders into a remote location. There are many others on the planet: cars, trucks, container ships, things that go across the ocean, trucks, people. It's really quite a global problem where there are not available connectivity solutions. And then the cost piece is also super important. And in his example, he was willing to write a check for whatever. He was at Apple, right? But many of us that want to go hiking or backpacking or want to connect millions of container ships, it needs to be affordable. So there's a kind of a gap in this space. And then more interestingly, there's expected, and we're seeing an explosion of Internet of Things devices, which are called IoT devices. That's just kind of a quick word for IoT. And this basically means any asset that's in a remote location that needs to be connected to the internet. Many people think of like smart refrigerators and toasters as IoT devices, and we certainly have those in our homes, but there are many of these devices that are also attached to any asset that might be in a remote location. It could be a crane, it could be a soil moisture sensor, it could be a tuna fishing buoy. You can imagine there are billions of devices out there that need to remain connected. And there's more and more of these devices that are being deployed. And then further, more and more of them require connectivity to be useful. If you have a buoy out in the ocean that can't connect back to the internet, that's not helpful at monitoring any sort of environmental aspects that it's supposed to be monitoring. So there's a real demand here for lower cost satellite solutions. And that's really what Swarm is going after. So many people in this audience will be very familiar with the fact that satellites have been getting smaller, and that's been a fantastic trend. So for example, the Iridium satellite constellations that were launched first in the 80s and 90s, and then more recently, are hundreds or thousands of kilograms in that range. There was an emergence of smaller satellites in the 2000s and 2010. People might have heard of Skybox or Terabella that was doing imaging that was eventually acquired by Google and then to Planet. And then the CubeSats, the small satellites that I worked on in grad school, about the size of a shoebox, 10 by 10 by 34 centimeters, that have been doing real science imaging missions with companies like Planet Labs and Spire, and a variety of really interesting things. And when Ben and I looked at this space, we realized that's pretty cool. Like, satellites have been getting smaller. That's great. But things haven't got much smaller since that CubeSat 3U form factor over the last 10 years when we were looking at this in like 2016. And we recognized that if we were going to really change this price point on this connectivity solution, we'd have to go down by at least an order of magnitude, or 10x. So we were actually able to develop the world's smallest two-way communication satellite. And I have one right here. It's actually blinking away, and I was warned not to touch that wire. So you can see it's like the size of my head. It's about 400 grams. Some of the more recent ones have propulsion systems, so they're a little bit heavier. And the way that we first developed this is that we threw out all of the traditional satellite equipment that makes satellites heavy and require more power, which means they become even heavier because you need batteries and power systems to support them, which makes them even heavier because you need thermal systems, which makes them even heavier because you need, additional kind of mechanical infrastructure. So we threw all of that away and we said, what if we could stabilize the satellite without the traditional thrusters, reaction wheels, star trackers, all of the things that take up the most space? And we came up with a way to stabilize the satellites passively using a combination of aerodynamic drag and gravity gradient. The space nerds in the audience will know what I'm talking about. These are essentially disturbance forces that you have in low Earth orbit, similar to how you have lift and drag on an aircraft. And the analogy we like to give is, when you throw a dart and it self-stabilizes, given kind of the offset of the CP and CG, it's kind of that trick that allows the satellite to stabilize. And then the antennas are pointed in the correct directions. And it's not a perfect stabilization. This is not like arc second pointing, like the JPL missions I worked on to do imaging of, Europa and stuff like that. This is loosely stabilized, but it's sufficient because we have a relatively uniform antenna gain pattern. So we launched our first satellites in about a year after we'd fundraised. I think it was early 2017. Or early 2018. And then we've since that time put up a total of 93 satellites on a variety of different launches. And what's really cool about our satellites is that the mass and volume of launch scales directly with the mass and size of the satellites. So if you make the satellite smaller, the overall constellation cost gets much lower. And we're at a point now where we're able to put up our entire network of 150 satellites for far less than our Series A, which was $25 million. And that's the first time in history that that's ever been possible because of the small size of the satellites. And then we've also leveraged the fact that electronics have gotten a lot more miniaturized, power systems are more efficient, solar panels are more efficient. So all of these things that we have in like our smartphones have really benefited Swarm as well in getting to that tiny form factor. So I talked about how we have 81 satellites on orbit, 81, and we launched 12, so yeah, 93 total. Another cool thing about the way we build the satellites is that we're fully vertically integrated. So we actually build every single satellite by hand in our lab, including the boards. And we do this because it allows us to be very agile. So we can launch satellites, learn something, iterate rapidly, and then launch new satellites a few months later. And then we also have full control. So we're not waiting for a satellite manufacturer. So for example, members of our team worked all through Christmas into the new year to finish satellites. You could never do that if you were outsourcing your satellites. You would just miss that launch. So like I mentioned, we have very unique launch economics, 10 to 100x lower relative to competitors. And then we'll put up 150 to get full global coverage. This is just a snapshot of our lab facilities. We're in Mountain View. We have a great 8,000 square foot facility where we build everything. And it's really kind of a few people show. You can see the guy in the green shirt, John, he builds most of the satellites. And then Ben also supports and does testing. We also do all of our own in-house testing. We have a thermal vac chamber. We can do Vibe in-house and all other sorts of electronics checkout. So it's a pretty lean but efficient team that's able to pull this off. I wanted to talk a little bit about the architecture because people might be wondering, like, how does this work? How is it different than a cell network or an iridium network? So we sell what we call the Swarm Tile, which is this small device. And this is an embeddable modem. So our customers embed this within a third-party product that could be an asset tracker, moisture sensor, really anything. And then they connect it with a small 8-inch antenna. And I have another device here that has that small-ish antenna on it that gets connected. And then whenever the device has data that it needs to communicate to the satellites, it will hear a satellite. The satellite will say, hey, I'm here, ready to transmit. The device will say, okay, I've got data, go ahead, transmit to the satellite. We acknowledge on every hop the data was successfully transmitted, and that ensures reliability of our network. And then the satellites pass over ground stations. Swarm has deployed our own ground station network. We have about 15 sites around the world. We'll soon have about 40. And they're on really great strategic locations, including Antarctica, the Azores, Hawaii, all through the US, New Zealand, Australia, so that we can downlink data very quickly as soon as it's uplinked. We also use a store and forward system. So the satellite can store data on board if it's over an ocean where maybe there's not a ground station in view. And then when it passes over a ground station a few minutes later, it can downlink that data. It's not the bent pipe model that some satellite networks use, so that we can actually bring back data from anywhere on the globe at any time. And then our ground station is connected all the time to our backend that we call the Swarm Hive. And that's, pretty simple cloud services system. And then we have APIs where customers can pull data or they can push data. And that's another aspect of our network. It's fully two-way. So you can send messages back to the tile, for example, to change a pump setting, to turn on or off an irrigation system, or to change the temperature in a container ship, for example. So that two-way capability actually enables control and autonomy, which is a huge value add for many of our customers. And then we also have encryption end-to-end to ensure that everything is secure and no one's data is sent kind of over the air and can be detected, which, that kind of checks the box on most people that are looking at satellite solutions. We're now commercially operational. So we have our 93 satellites. We have many customers joining the network, usually 2 or 3 a day. So it's really fun to see it ticking up and up and up with the number of devices and number of customers. We're doing pilots all over the world. We have the full approval from the FCC. That's a huge part of launching a satellite network, is getting the approvals, of course. So we have approvals from the FCC to launch and operate. And then we have market access in multiple countries around the globe. And our biggest markets in particular, we have Canada, Australia, New Zealand, US, and all through Europe. We're working on Africa and Brazil and many other countries. So that will enable customers all over the globe to benefit from this. And we are fully funded. So we've raised all the capital required to launch our full network of 150 satellites. We've signed all the contracts. So we're good to go, and we'll be fully deployed by the end of this year. And once we're fully deployed, our network will look like this. So as you can see, the satellite orbits are in kind of different orbital planes. I describe this as kind of like an orange. The wedges of the orange all need to be filled in to get that full global coverage. And we get that by launching, we ride share on a variety of different rockets, Rocket Lab Vega, PSLV, anyone that we can get a ride with SpaceX. And we go on rockets that are going to different LTDNs, which are just the crossing time. And these are all sun sync orbits, and they're low Earth orbit, polar orbits. So we get diversity in that crossing time that gives us that nice wedge of orange look. And then we have a trick where we weight all of our satellites slightly differently. So they all experience a slightly different amount of drag, and therefore they spread out relative to one another like a string of pearls. And we've actually just started flying some active attitude and orbit solutions, active magnetorquers, and then some propulsion systems that will allow us to do that spreading and then to maintain orbits even better. And we put up 150 satellites, which is a bit of redundancy. We actually only need about 70 satellites for global coverage, but they're not always perfectly spread out. And we want a bit of redundancy and overlap of the satellite footprints that you can see. So that's why we've launched 150. And you might at this point be wondering, like, how do we compare to other connectivity solutions? So I like this plot. It's basically range or distance on the x-axis and then cost on the y-axis. And if you look in the far left-hand corner, you see a lot of terrestrial solutions. So there are technologies like LoRaWAN and Sigfox and Zigbee that are doing very low-cost terrestrial solutions, but very localized. So typically within kilometers or tens of kilometers. So really don't expand to that global scale that Swarm does. And then of course, there's all of the cellular networks, which are great if you're in or near cities. But of course, there are struggles with that. I actually don't have cell at my house. And I think that's a pretty common problem where people have, if they're not close to a city or there's terrain or there's just, something that's not allowing them to get that coverage. So, it's great if you have it. If you don't, you're kind of out of luck. So then as we look on the global scale, so way far to the right, and this is, think of it as more as a log scale than a linear scale, we have the satellite solutions. And we have the legacy satellite solutions at the top right-hand corner. So that's Iridium, OneWeb, Iridium, Orbcomm, GlobalSat, things like that are very, very expensive legacy solutions, but they do exist. And then we have the highly capitalized constellations. So obviously Starlink and OneWeb and Kuiper are starting to propose these new solutions. They're mainly doing broadband, which is very different than what Swarm is doing. We're focusing on small amounts of packets for assets and people in remote locations, but still very interesting. And then there's other small sat startups, so our competitors that are emerging. So companies like Hyber and Myriota and Lacuna, that for the most part only have a few satellites up and are probably a few years behind Swarm, but are doing something similar. And then there's Swarm, and our price point is very low. And then we're also available today. So that's one of the key differentiators is we're commercially available. We have customers joining every day. But hopefully this gives you kind of a landscape of how we differentiate relative to the others. And then you've probably been wondering, what are the types of applications where Swarm is useful? So we see a lot of traction in agriculture, probably the most in soil moisture monitoring and sensing. There's also quite a lot in monitoring assets, so tractors and trucks, and just being able to have really good health and status of what's going on the farm and then throughout the logistics supply chains, as often these are in very rural and remote locations. And farmers are getting really smart and they're optimizing their use of water and pesticides and all of these things. And they need a lot of sensing capabilities in order to make really smart, informed decisions about whether they should water, whether it's time to bring in the crop, how they're going to keep their soil healthy. So we find a lot of use cases in the ag tech space. Another is in the logistics space. So this is a little bit more straightforward. We want to track trucks and assets as they go across highways, across railways, and across oceans. And this is really important for kind of health and safety of the drivers and the people working in this industry, but also just to know, where the trucks are, how they're running, kind of their health and status. And if anything funny is happening, like they get lost or they're not taking the most optimal routes. And this is a space where Swarm has the opportunity to help logistics companies be safer and healthier, but also try to reduce their emissions by having more efficient kind of path planning and knowledge of where everything is. There's also quite a bit of applications in the environmental monitoring space. So being able to monitor, one of my favorites is fire detection. We have several companies that are working on fire detection capabilities, and often those are in very rural and remote locations. So being able to know whether or not a fire has started so we can stop it before it spreads through all of California. And then also just monitoring things that are helpful to know in terms of climate change. So lots in that space, and others in the energy space. So solar, wind, oil, and gas. We see a lot of monitoring, electricity monitoring, things like that. And then in the maritime space, obviously there are a lot of shipping vessels and buoys in remote locations that have no other solution. So satellite is a natural choice there. And then in the global development space as well. So trying to monitor things like pumps, making sure water supplies are healthy and still functional. We see quite a few applications in that space as well. And there are many more that are not captured here. We hear about lots of random applications every day, monitoring beehives and monitoring scooters and bikes and kids. So the applications are really quite broad. And it's really fun to hear about all the ways people want to use Swarm to improve their lives, really. So these are our two products. I talked about the Swarm tile that is available today at $119. And then our data is really where we stand out from a cost perspective. So we offer 150 kilobytes per device per month for $5. Someone made a joke, this is like less than a Netflix subscription. I really love that line. And just to give you a sense, this is about 4 to 20x lower cost than legacy solutions today. So you can see why people are quite excited to switch over to Swarm, and often results in being able to lower prices or increase margins, and be able to expand into new markets are kind of the main value props. I wanted to talk about some of the use cases just so you guys got a sense of how real this is and how this could impact the world. So SweetSense is an amazing company. The CEO was also cut from the Canadian astronaut program, although he made it a little bit farther than me. So we have that competition going on. They do a lot of work in global health, and they do very low cost remote monitoring of water pumps, filters, boreholes, all across East Africa. And this is a really interesting use case where by being able to reduce the cost of using Swarm, no longer Iridium, now Swarm, they're able to reduce their operating expenses and then expand the number of pumps that they can support by 5x. So improving people's water supply is a pretty significant impact on the world. And we're very excited to be working with them. They're also expanding to do some water monitoring and drought management work here in California. Another company is SoFar. They have these very cool buoys and kind of this diving system that does a bunch of oceanic monitoring for environmental monitoring purposes. And we are also able to result in significant cost savings for SoFar, so that they can increase their margins, potentially reduce their prices, and then enter new markets. So also very excited. And this is another Iridium replacement. This company is also in the Bay Area. And then there's this cool company, LayerX. They do a bunch of kind of full service IoT work across industrial and remote IoT, a lot of beehive work, but expanding into different areas. And they have developed this gateway, which actually you can buy today. So you can go to their website, and their website is ModuSense, which is kind of a daughter company of LayerX. And they're able to significantly reduce their costs and therefore enter new markets again and increase their margins. So this is a real available commercial product today with Swarm. HiveMind is another example of a product that's very close to being commercially available. They do a variety of remote beehive monitoring, but they're also expanding into a more broad set of agricultural and industrial IoT applications with Swarm. And they're really hoping to increase their revenue and expand their margins and market opportunities as well. So it's a very cool company. And then Easy. Easy is super interesting. They do a lot of kind of remote automation and control. And the fact that Swarm is two-way actually enables them to be able to offer this service. They have kind of this like one thing fits a bunch of different applications. So any equipment, application, volume, and they've added location now with Swarm because of our global connectivity. And this is an interesting one because they are actually coming off of 2G, 3G, and Cat-M1 onto satellite for the first time. So they could never afford satellite before, but with Swarm, they're actually able to provide that true global operation and expand where they can be applicable. And they have a product that will be available very soon. They're doing a campaign advertising that right now. And just kind of a snapshot of what Swarm has accomplished. So we started in 2017 with a seed round of just shy of 3 million. We launched our first satellites in about 11 months. We did some pilots with paying customers around the 2018 timeframe, also raised our Series A in August of that year. 2019 was a big year for us because we got our FCC license to launch and operate our full network. 2020 was, first surviving COVID, but then also launching our first commercial satellites and starting commercial operations, which was very exciting. We put up a lot of satellites really fast. We went from, I think, 20 satellites to 93 in a few months. So that was a huge ramp up. And then 2021 has really been about commercial offering, continuing to launch the network and getting customers on the network, making them happy, helping them expand and scale their businesses. And I was asked to also talk about the future of connectivity. And I took this early slide to where I think we're going to be really soon here. So first of all, 100% of the Earth's surface area will be covered very soon. And I think that that is super important to a variety of different applications. I also think that bringing a cost of connectivity to an affordable price point around that $5 per month, maybe even lower in the future, makes it a lot more accessible to a lot of people. And I'll kind of separate out how I think this will affect the world into people and then devices. So on the people side, I think connectivity is key to things like safety, security, being able to call home if you're in trouble or if you get lost. And I think that that's something that we should all have access to. And we have the technology, we can do it. Also just access to basic things like weather and logistics. So that helps farmers make decisions, that helps people working in supply chains to make decisions. And then also, giving people connectivity allows them to have access to education. And that's obviously a huge discrepancy we currently have in our world today. And we hope to contribute to overcoming that discrepancy. Also access to things like finances, healthcare, and the ability to start businesses obviously is super important to have connectivity to do any of those things. And then on the devices side, I think there's a lot of opportunity to improve efficiency across a variety of different verticals and applications. The agriculture one is obvious. If we can have better knowledge of how our agricultural systems are operating, we can reduce the amount of water required, we can reduce the CO2 emissions, and we can basically run more efficient, optimized systems and just more efficient supply chains, really. On the logistics side, there's again, a variety of different ways that Swarm can help improve and other connectivities can help improve as well. I think things like the vaccine supply chain, so knowing where vaccines are and keeping them at the correct temperature is a pretty top of mind one where connectivity is required. And then across supply chains, being able to know where assets are, whether that's trucks, trains, or ships, and then help them plan better routes, which leads into having better weather predictions, can result in less CO2 emissions as well. And then across the environmental monitoring space, we can have much better visibility to what's going on globally in terms of climate change and all of the global changes that are happening and global weather trends if we had better connectivity solutions. In the energy space, again, having better access to knowledge of what's happening with solar, wind, oil, and gas across the planet, better visibility into our supply chains and power systems, and better monitoring. So, I think that connectivity should be ubiquitous and at a price point where we can enable all of these great changes to our future world. And I see that happening, and Swarm is a piece of that puzzle. And there are many other pieces, of course, to that puzzle as well. And we're really passionate about solving for connectivity, and very excited about what we can do now and in the future with this cool technology that we're bringing to the world. And then I'll just have a little plug. Swarm is always hiring. And here are just some of our roles. I encourage you to check out our roles, swarm.space/careers. Even if you don't fit into one of these buckets, but you want to join and you have a compelling story and you want to work really, really hard, you want to work on something that is very mission driven, and you're scrappy and can survive in a small startup environment, please do reach out. We always love adding incredible team members to our team. And then the last thing I'll offer is that we have an opportunity to send messages to space to yourself, a colleague, or loved one to their email. If you go to this Google form and type in that message, we'll send it through one of our satellites over the next few days. And we'll also share that in a chat so you guys can access that more easily, just so you can see for yourselves that the Swarm network is real and alive, and get to experience a little bit of its magic. And then this is just some info on Swarm if you want to reach out to us, or add us on LinkedIn or Twitter or whatever. Always excited to have more people involved in following Swarm and cheering us on, hopefully. And with that, I think I'm done. Hand it back.
Thanks, Sarah, for such a great presentation. We got tons of questions, so I will just go straight to ask you the first question. So what are some considerations behind choosing certain orbits for the configuration? How do you select the number of nodes, spacing, the orbits?
Yeah, great. Well, I'd love to talk about this for hours. This is one of my favorite topics. So I think the first thing is deciding what type of orbit you want to be in. So a low Earth orbit is satellites that are going around the Earth every about 94 minutes. And they're tricky in a sense because you're going in and out of eclipse and you don't really hover over any one point of the Earth at all time. But if you could put up a network like we're doing into these very specific sun sync orbits, I view the orbits kind of like a bunch of locked hula hoops, so that as the Earth goes around the sun, they stay fixed relative to one another. So you always have this global continuous coverage. It's kind of this like really cool kind of sweet spot of orbits. I don't know who came up with it, but I credit them because it's super valuable. So you see a lot of networks, particularly communications and some imaging networks that are like this in low Earth orbit. So that was kind of the obvious choice for Swarm because we're focusing on connectivity. There's also geostationary orbit, which is way farther out orbits. Those are typically very large satellites with really big beams, and they can see a third of the Earth at a time. So that's very efficient from like a coverage perspective. But those satellites have to be very big. They have a bunch of radiation challenges, and then they're also really far away. So if you're trying to do communications, typically communication scales as 1 over the distance squared. So it really, really hurts you to be really far away. So you have to have more power, bigger antennas, bigger stuff on the ground. So that's typically used for like TV networks and things like that, where they can afford to do that. And then there's kind of like the kind of like middle or medium Earth orbit, which is not really used that commonly. There's some things that make sense to be in those types of orbits. So I would say like that's your big decision, like decision 1, what type of orbit? Okay, I'll be in low Earth orbit or LEO. And then after that, because we're so small and we piggyback on rockets, we have to kind of pick orbits where we can piggyback. We can't just say we want to be in this perfect orbit and someone's going to take us there, although that's changing with some of the rocket companies. So we had to look at what's available. So there's a lot of availability to like 400 to 550 kilometer altitude, which is a little bit higher than the space station. And then there's a lot of access to sun sync orbits, and that's the kind we want to get these locked orbits. It is challenging to get some of the more strange planes, some of the LTDNs. So I'm always whining about LTDNs to my team, and they think I'm crazy, but it's really important to get the weird LTDNs. So we've been able to work with some of the launch providers directly and, kind of make a deal like, okay, well, you take us to this orbit and so forth. And they've been awesome. And especially with all of the new rocket companies coming out, you're able to get into some of those orbits. So sorry, that was kind of a long answer, but I could talk about that all day. Orbit selection.
That's great. Thank you so much. Okay, so the second question is, so you have a diverse life experience, PhD student, becoming an astronaut. What are some of the challenges now as the CEO and co-founder of Swarm, and how did these previous experiences help you solve these challenges?
Yeah, totally. I do have a lot of different experiences. I think having experiences in academia, government, and industry, and particularly kind of more startup industry, has been really valuable because I've seen the academic way of doing things, the government, NASA, JPL way of doing things. And I mean, JPL lands stuff on Mars. This is like really, really cool. And it always works, usually always works. And it lasts forever and it's super robust. So it's really great to know the NASA way. And then there's the industry way that's a little bit more like, oh, I'll just hack it together, see if it works, iterate really, really quickly on that. And then a startup is a little bit different too, because you have very limited resources and you have to, move really quickly and not waste resources and make decisions. So I think having seen it all is kind of like having a toolkit to pull from. And then whenever we're faced with something, like if we're dealing with, like a hot topic, like collision avoidance, I pull out my academic and my JPL hat because that needs to be done really rigorously and really correctly. If we're dealing something where we're doing like a quick demo to show we can connect to a vehicle, maybe that's more of the kind of industry experience. So I think it's just different skill sets and being aware of which one you're picking from to deal with different situations. And the challenges I deal with now, I mean, it's not really technical. It's a lot of like people stuff and trying to grow the team and, just trying to do something really, really freaking hard. Like it's kind of crazy to think that we were like, yeah, we're going to start a satellite internet company 4 years ago. And now we're doing it. But like, no one's ever done that with $35 million and 30 people. And we were a lot less for a lot longer. So it's just balancing expectations with reality, trying to move fast, trying to do something really, really hard. And like everything's hard. Regulatory is hard, tech is hard, business is hard, and just balancing it. So I don't know. I don't know if that answered the question, but I hope that was helpful.
It's perfect. Yeah, I can imagine that everything is very hard. So the third question is, can you talk a little bit about how the communication is delivered? Like, does each satellite independently collect, store, and forward the message until it is over a ground gateway, or are there any inter-satellite communication links?
Yeah, definitely. So we played around with a lot of different architectures when we were first thinking about Swarm. And for most of our use cases, it's connecting an asset that doesn't mind if it has to wait a few seconds or even a few minutes in many cases. So we didn't need to do the inter-satellite links. That's if you want to maintain kind of like a live IP connection for people that are on the phone or something like that. And it's quite a bit more difficult. Like we would have had to make our satellite bigger, very likely to do the inter-satellite link part. So we decided to go with a more simple form factor. And everything is stored forward. So a single message will go up to a single satellite down to a single ground station. And then another satellite will pick up the message from the next device. So that's the architecture. It's not as sophisticated as it could be, but we find we don't need to focus on this kind of Internet of Things applications.
Great. And then one of the popular questions, what happens to the satellite at the end of their lives? Do they active deorbit? What mechanisms do they use?
Yeah, totally. So we put our satellites into these, like I mentioned, low Earth orbits, and they're actually always deorbiting a little bit. So there's a little bit of atmospheric drag. They're slowly coming down. And then once they hit a certain altitude, they actually just burn up into the atmosphere. Nothing comes back down to the Earth because our satellites are so small and we pick the right components. So that happens. So we call it kind of a self-cleaning orbit. And that takes about 4 years, sometimes a little bit longer. So we're very intentional about which satellites we're going to put up into which altitudes, and then we monitor them, and then we'll replenish the constellation as needed when they deorbit. And most likely we're going to want to fly the latest and greatest anyways. And then, like I mentioned, we're going to fly some propulsion systems, and that will allow us to deorbit even quicker if we want to bring down some satellites to put up fresh ones.
Great. And also related to this, also another popular question. So there are some concerns that satellite constellations can interfere with the ground-based telescopes. Are there some precautions that Swarm is taking in order to mitigate this interference?
Yeah, there was a lot of kind of media around that in the Starlink satellites maybe a year or so ago. So luckily the Swarm satellites are so small that you can't see them, so they don't cause any sort of pollution. I would think it would be cool if we could see them, but we actually just can't because they're so small. So it's not a concern for us. And we actually have someone that does that type of imaging on our team. So he's remained very sensitive and helped us make sure we make the right decisions to make that true.
Great. Also, do you consider in the future maybe putting some other instruments like cameras for future Swarm satellites?
Yeah, we've definitely talked about it. You require pretty accurate pointing to do imaging, and there are a lot of other companies focusing on that right now. So it's not an obvious market that we would go after. We could probably fly a small sensor that was just doing some sort of monitoring in the atmosphere. If I'm sure there's a JPLer that has an idea of what we should fly if it fit on our form factor. But we're really focused on connectivity. You can see that's what we're really passionate about, where we see the use cases. So we're mainly focusing on that for at least, the short to medium term here.
Super interesting. So let's do two more questions.
Sure.
So do you plan to expand the constellation in the future? You mentioned you plan for 150 satellites. I don't know, in 10 years, how do you see Swarm?
Wow, in 10 years. In 10 years, I think we'll probably have launched at least one, if not two, different constellations. So we've certainly been thinking, and I can't spill the beans here, but we have ideas for what we're going to do next. And the natural progression would, of course, be bigger satellites, maybe, or maybe smaller, that can do way more data and connect more types of devices. So you can imagine connecting to cell phones and things like that. So we definitely have aspirations of additional kind of demand curves, we call them, of things that we could do in the future. And we've made some progress towards those, but you'll have to stay tuned, and maybe we'll spill the beans in a while. So yes, of course, always the next thing.
Great. And if someone wants to start a company, especially in the space sector, what advice would you give? How should we start? What are the first things we should look into?
Yeah, so starting a company is really, really hard. I'll be honest with you. I think that if you want to start a company, it's kind of like starting a PhD, which I'm sure you know because you're doing that. It's really important that you're passionate about the reasons that you're doing it. So the problem that you're solving or the thing you want to bring to the world that doesn't currently exist. Because if you don't have that like driving passion to do that thing, the other things will totally knock you down. Every day things try to knock you down, and you just need to have like this kind of undying, irrational passion to do this thing, because that's all that will get you through. And I think that, often being a founder is kind of glamorized, and it's really not very glamorous. Like I had to like actually take a shower and, put makeup on and stuff for this, but most of my days are like in my pajamas, just trying to get stuff done. And it's a lot of hard work, and you're responsible for literally everything, whether it's accounting, finance, HR, recruiting, business, tech. At the end of the day, you're responsible for everything. And that's a huge responsibility to take on. So irrationally passionate and willing to work harder than you've ever worked in your life and be pushed to your limits pretty often. And really be honest with yourself if you want to do that. And if you do, like you probably have a better chance than not to succeed. So yeah, that's probably it.
That's great. Actually, it seems like we have time for one more question.
Okay.
Of course, because of the pandemic, it's normal to ask such a question. How did the COVID have an impact on you personally, but also on the business?
Yeah, it was really tough, right? We were all kind of cooped up, and I, personally, it was tough. I, at that point, lived in a really small apartment, and I missed just the energy I got from being in the office and seeing what was going on. I think from a company perspective, our team was really amazing. Everyone transitioned to remote work very quickly, very few complaints, just like we're going to just do this and get things done. We were able to keep our lab open with one individual who could stay COVID safe because he was the only person there to build satellites, which is obviously very key to our business. And, definitely there were mental health kind of concerns and challenges. I think everyone on the planet probably experienced that, but especially in a pretty intense work environment. So just trying to find ways to support those people, and then to get people back in the lab in a safe way. We've had very strict protocols throughout, mask wearing and doors open and all of them, testing and all of those things that have kept our team really safe and healthy, which I'm really proud of, actually. And then, just we got work to do. So just keeping the work going. And I think in some ways we were actually more efficient. There was a lot of progress on regulatory and the business side, as well as on the tech development side, because people were able to spend more time thinking and in their home labs and things like that. So there were some interesting silver linings. And I actually was able to buy a house with my boyfriend in this time. So that was a kind of silver lining. So pretty happy to have more space. But I don't think we did that without COVID. So maybe that's one upside. But yeah, and then now, it's about getting back. So how do we get vaccines? How do we get back in the lab? And then, recover. We had a lot of launch delays due to COVID, particularly in India, but New Zealand, et cetera. So we were delayed to launch. So sometimes I feel like we're kind of playing catch up, but I also feel like we're on a really good path and we're making tons of progress. And, COVID hit the whole world. So it just kind of is what it is. Let's just keep making progress.
Great. Thanks a lot for your time tonight, Sara. Also, I think he sent you a small gift, so it will be great if you can unwrap it in front of everyone.
Okay, cool. I do have the gift. I think the wrapping paper is missing. I'm sorry. Okay, what is it? I need a drum roll. Woo! Cool. Okay, so I think it's a coaster, and it has our swarm constellation on it. This is awesome. Thanks, guys. I can have a really nerdy coffee table.
You're welcome.
Thank you so much. Appreciate it. Got 4 of them.
Great. Thanks a lot for being with us tonight. And
Thank
I hope
you.
you will enjoy the coffee now with new coasters.
Oh, yes. Lots of coffee. Thanks so much.
Okay. Thanks, everyone, for joining us today. Please keep an eye on the KISS website for the upcoming lectures. Good night.